Okay, I should be live again. Sorry about that. Yeah, so it should be in sync. I have no idea why it's going in and out of sync. Let me try something really quick. Okay. Okay. Wait. I think maybe I figured it out. I'm messing around a little bit to see if I can re-induce the lag. Wait. Give me a second. Is this broken? I think I think I'm completely broken now. 1 second. Wait. Now I'm complete. Wait. Mission accomplished? Yeah. I'm definitely broken now. Okay, so I've figured out what the problem is, which is great. Yeah, I've definitely figured out what the problem is. I don't know how to fix it, so I'm going to fix it. I'll be back in like an hour or something. Yeah. All right, I figured it out. Cool. Wait. Okay, so now I'm up, but I should be incredibly out of sync. Now, is there a way to resynchronize the camera? Let me see if I can figure something out. So what's happening is I've got two monitors, right? And what I have to do, I've got two monitors and then I've got one tablet, right? So when I switch between one monitor and the other monitor, everything lags for a second, but I thought it was just the input lagging. I didn't think it was like the entire computer lagging, but I think I just lose a few frames every time I switch between the different monitors. So then what happens is everything gets out of sync. Okay, so how do I fix this? I need to, can I refresh the video device? Am I allowed to do that? 1 second. Yeah, but it's really annoying for me. Camera controls, defaults, auto reset on timeout, focus, auto. As long as your corner layout. Yeah, but I get annoyed by stream offsets and stuff. Can you reset, auto reset on timeout? What does that do? Maybe that? No, that doesn't help. Can you just reset? How do you do it? Screenshot group. Okay, I'm gonna Google some stuff. Sorry about that. As long as you can use X input to disable and enable the camera. Okay, well I have X input anyway. Let me try over here and let me run OBS. Oh wait. So I can use X input. Restart camera. This will probably break OBS. OBS breaks all the time. It's such a pain. Agree. Let me see. What do we have here? No. Just give me a command. All right. Let's go here. Okay. How can I disable my webcam? Restart is what I want. No, yeah, I definitely want to restart the camera. How to disable built-in webcam? How to disable your laptop's webcam? No. I don't want to disable anything. Give me a second. 1 second. So we want file. Wait. What am I doing? All right. Sorry, guys. This is gonna be really annoying. Give me a second. Yeah. Okay. Let me just try to fix this. Because it's super annoying. Like video and audio desync just pisses me off. Like genuinely makes me angry. It's something I've been dealing with for like 6 years of streaming, and I just can't deal with it. So if there's a way to like quickly reset the camera, that's one way to fix it. Let me see. The other thing to do is X input disable ID and X input enable ID. X input list. Probably double dash list. Okay. Obviously we have all this. That's fine. Let me open it up in UX term. Okay, so we have virtual Intuos, obviously. I don't see anything. Oh, there's a pro webcam. Okay, so this ID is number 14. I think it's probably always 14. So we want X input disable 14. That did nothing. Okay, enable 14. Yeah, that's obviously not doing anything either. Do I have to do sudo? I don't think so. Yeah, no, obviously not. Okay. Let's just do restarting. Let me mess with this really quick. Oh, come on. Let's see what we got here. I try to fix whatever is unplugging your camera. That's not the issue. Reinitialize the camera midstream. If I go to the camera properties and enable custom resolution, then disable it, and then I reinitialize the camera. Okay, good. Let's try that. So we're going to go here, settings, and then we're going to change the resolution to this. And then we're going to change it back to this. And then that does fix it, I think. So no, it should be fixed. That is super dumb. But if it fixes it, it fixes it, and that's good enough for me. I think that's fixed. Yeah, that looks great. Okay. The only other thing I'm going to do, try 8. I could try 8. Wait, what's going on? Oh, here. And then every time I switch, okay, there's one other thing I need to do. Let me go ahead and fix that now. So let me do X input, a double dash list here. And you said try 8. What is ID 8? ID 8 is the 930. So the 930 is somewhere else. So it's definitely the 920. Okay. That's fine. We need to debug things so that we can debug things. Yeah, I'm sorry. That's how everything works, you know? Like everything is a debug on a debug, you know? Okay. So what am I going to do next? The next thing I want to do is actually do one more thing that is kind of, it doesn't make sense to you guys, but makes a lot of sense to me. Which should also help alleviate the problem. We're going to cd into projects and then go to utilities, ls here, and then we're going to go into vi set wacom 1. This is a thing that allows me to go between one monitor and the other monitor. Let me do x input list again, and it looks like 12 is the only one I need. So what I'm actually going to do is I'm going to go here and I'm going to comment these guys out. And I'm going to do the same with 2. There, and now it should be that if I do this guy, it should bring it over here, and if I do this guy, it should bring it over. That's 2, that's 1. Okay, so now there's not like a huge delay. There's a small delay, and I think it will still go out of sync every now and again, but I think it's relatively easy to fix. So again, I can just go here. You guys don't see what I'm doing, but if I just change it really quick, that'll fix it. Okay. Okay, good. We have the solution. That's fine. Here. And the other nice thing about that is I now have the ability to go from one monitor to the other monitor with another stylus, which is quite nice. But anyway, this is good. This is good. This is actually what I want to see. Right. Perfect. You guys have no idea what just happened, but I just solved a big problem with the usability of this computer that, again, people had no idea was an issue until just now. So anyway, let me get some water. I'm really sorry about that. MB Mia, thank you so much for following. But I'm super happy that we have the solution for the video and audio desync problem. The only other issue that I have is workaround is not a solution. Well, yeah, okay. Look, it is a solution in that you can fix the problem regularly. It's not a super nice workaround, like, but it's fine. Like, at least it does kind of solve the problem. Mia BDI4, thank you so much for following. Really appreciate it. Okay, with all that said, we can finally start tackling the Euler issue again. So essentially what we did a few days ago is we were trying to figure out the Euler method. And yeah, obviously, you know, the Euler method is super easy. We did it a super long time ago, but I had forgotten everything about it. And here too, I have apparently forgotten everything about it. So I've forgotten to multiply by dt. No, wait, what? 1 second. The plot that we're trying to recreate is x cubed over 6. That's the plot we're trying to recreate. Let me just go ahead and do plot of Euler. Now let's see what we got. I mean, look, I'm quite happy with the solution that we have. Again, the workaround we have then. Okay, so that's x cubed over 6, should be. Just to double check, what is 10 cubed over 6? What is that? 166 sounds correct. So that means these guys are actually incorrect. But I think they're incorrect because I forgot to re-include this. So let's include it again. Now we're going to do Euler 1 is equal to this. Perfect. And Euler 2 is going to be equal to this guy. And right, perfect. Almost perfect. Let's fix Euler 1 again to be 1 and 10. 1.0 and 10 because floating point precision. And now let's just plot all three of them. So the first thing I'm going to do is plot Euler. The next thing I'm going to do is plot on top of that Euler 1. Perfect. And the next thing I want to do is plot Euler 2. Now this one is on a different scale. I have to figure out how to put them on the same scale, but that's, you know, it's kind of okay. Yeah, right. Right, okay, so another question as to what we're doing. Let me go over here, let me go to the algorithm archive. Right, so we are writing an online textbook for algorithms. So for example, here's the Barnsley-Fern. I think we have this in a few different languages, perfect. And so it kind of talks about what the Barnsley-Fern is, how it works, what all the different transformations are. You know, here's, are you gonna play or not? Here's one transformation. It kind of shows how they work together. Like for example, here's some visualizations of how it works on the entire fern and, you know, all this kind of stuff. And then at the bottom here, we have basically a bunch of different code that you can switch between for a bunch of different languages. So the idea here is that we're trying to teach algorithms as you would in a textbook, but we're also trying to provide like language implementations in pretty much every language that we can support. Now you might ask, what are the languages that we can support? That's a super good question. It's ultimately down to whatever languages the community can review. So if they can review Coconut, Coconut gets in. If they can review Haskell, Haskell gets in. But you know, if you want to review LOL code, then you need someone to be able to say, hey, this is good LOL code, right? So stuff like that. And anyway, so we have like convolutions, a bunch of different things. So right now we're working on the Euler chapter, which I wrote like a super long time ago, and I've completely forgotten how the Euler method works. But people were arguing that, or someone had sent me a message saying a couple different things. The first thing they said was that I might actually pull up the Discord conversation in just a second, because I'm actually a bit confused by what they said now. But we'll get to that in just a second. So the first thing it said was that the Taylor series expansion that we had written down was incorrect. And so I looked at it, and I actually was fairly convinced that it was correct. Now, admittedly, the notation is a bit funky. We fixed the notation, but, you know, I'm fairly convinced that that was correct. And so the next thing we had to do was update the plots. Specifically, this plot is really, really misleading because the red plot is on a fundamentally different axis than the blue and green plots. So we need to fix that. But this plot here doesn't seem to have a problem. And they told me that there was definitely a problem. About good code, there's an algorithm that uses std vector of std vector double in C++. Yeah, go ahead and which algorithm is that actually? And also, yeah, go ahead. Which algorithm is it? And I can take a look at it. If I'm honest, right, like you know, back in the day, I used to do C++ implementations, and you know, it could have been me that wrote that. I don't know. Gaussian elimination. Let's take a look. And let's go here. So if I wrote that, I probably would have done a double star star is what I would have done, not a vector of vectors. So let's go to C++ algorithm here. And we can do a git blame, but it doesn't really matter too much. Oh yeah, this is definitely not my style. Yeah, I would not have written this. Yeah, this is not me. Not that I'm blaming the person that wrote it, but I'm saying it's not me. If you want to update it and you have a clear reason to do so, feel free to do so. Now, it should be the same as C? It should be close to, no, C should be, I mean, obviously C is going to be used double star star and stuff. It's going to be using different notation. A double star star is different than a vector of vectors, right? In how memory is allocated and stuff like that. What I will say is if you want to update the C++ code, feel free to do so. However, I need to bring up a big caveat here in that C++ is one of those languages that is like next to impossible to review. And the reason for that is that like it's just really difficult. Like C++ 14 is dramatically different than C++ 98 or whatever. And so, as we start like saying what is good idiomatic C++ code, I mean, we can basically say use the Strausdorf style or whatever the style is. But after that, it's like, it's super difficult to be like, this is good C++ code, because some people write C++ in a functional way now, as opposed to imperative code. And they'll always argue that, what we probably want are like, heavily templated metacode. And I'm like, well, actually, probably, if we're trying to teach people the algorithm, the heavily templated metacode is going to distract from the algorithm and actually make it more difficult to read. I don't know. That's the big problem is everyone has different styles and definitions of what is good, right? With some languages, it's like it's super easy. Like it's really easy to say, this is good Julia code, this is bad Julia code. And now I say that knowing that I probably write bad Julia code, but the point here is saying that there are some Julia abstractions that I'm like, this is good, definitely do that. And there's other Julia abstractions where I'm like, actually, maybe you're taking a step too far with this. In that, the whole point is to teach the algorithm, not to like explain some interesting nuance about Julia, the language. I don't know, right? Good C++ could be about 10 different things. C++ is many languages overlapping because the language allows various paradigms. Right, exactly. That's the problem with C++. Now, that said, if you want to update the code, feel free to do so. What happened is when we tried to do C++ before, we ran into the issues that we couldn't get anyone to review the code because everyone was afraid that other people, like, it would get heated. People get really, really angry. Why even write in different languages? Why not pseudocode? Or maybe just Python? Just something where you don't even care about style? Yeah, so, for example, whenever I write an algorithm, I write it natively in Julia, right? That's just what I do. I think Julia, for me, is a language that's easy to express myself in. It's something that makes sense for a book like this. I don't like pseudocode because the problem with pseudocode is that even the best pseudocode will ignore key problems with the actual implementation in certain languages, right? So, like, you can say, it's like the whole point is to give people actually usable code, to be like, yo, this is how you're actually going to do this. And giving people pseudocode does kind of give them that. But there's also a big difference between pseudocode and an actual language. Right, you can't play with pseudocode. That's kind of one answer, but the big answer is just that, there is no idiomatic pseudocode. So as much as we're sitting here and arguing that, this C++ is not super well written, or this Julia language isn't super well written, it doesn't follow standard guidelines, at least there are guidelines. That doesn't exist for pseudocode, Pseudocode is basically Python. I disagree with that. Pseudocode, to me, my pseudocode is usually closer to Julia than Python. I find a lot of things about Python quite... I mean, a lot of people, it's good. Like, don't get me wrong. It is a nice, higher level language that's easy to implement stuff in. But I do not think it is basically pseudocode. I think it's quite far. But also, like, yeah, again, what is pseudocode? Like, it's some people will just create like giant listings in LaTeX, and that's what they do. I don't know. The problem or reason it stayed ubiquitous, is because it has all the different paradigms, right, for C++. Is he already complaining? Kappa Kappa. I'm always complaining. You've been to this stream multiple times. Like, the entire premise of this stream, it might as well just be rebranded as Ramboleos or Leos complains about X, Y, and Z. Like, that's what I do. Like, don't bring up MATLAB because, like, oh boy, that's going to be a rant. I shouldn't have said that. I should not have said that. I'm not going to go into a MATLAB rant today. Let me get a little bit more water. Anyway, so as far as the C++ language is concerned, feel free to implement, just to say, hey, this is how I would write the C++ code. But I don't know how quickly that PR is going to be merged because we need someone to review it, and like that's just going to get angry. He will go full Eminem. I don't know what that means because the only thing I know about Eminem is that that person is a rapper. That is all I know, and I know nothing about it. So this goes back to the pop culture references that I was talking about earlier. I know nothing about it. You could say that I could say that Python is nearly pseudocode, but to say that pseudocode is Python is completely wrong. Wolfram for president. So maybe, I don't know. Is that a good idea? Probably not. Okay, now, yeah, so, but like to me, Julia is also pseudocode, you know, like it feels like pseudocode when compared to C++, you know, but also like sometimes people just understand code when it's written, like they understand an algorithm better when they see code. At least for me, that's true. If I see code that goes with a particular thing, I can then start to piece it together and I can tangibly grasp what I'm looking for. And allowing all these different languages really does help with that because it means that, like, you know, let's say the Julia implementation isn't good, but you also know Python. Well, then you can look at the Python implementation. Or let's say you happen to only know C. Well, then we give you a C implementation, which is the language you know and the language that you should be able to understand the algorithm in, right? Like, I don't know. I feel like it helps people learn when you don't ignore the actual details of implementing the code in a like real language. Okay, that's me ranting. I'm sorry, I've been ranting a lot. Okay, so I'm gonna do something. I want to do something that is probably not a good idea. So maybe you only know lol code. To be fair, if you only know lol code, you're in luck. There are certain algorithms that have lol code in there. So if you go to, I think even Monte Carlo has lol code. No, but definitely the Euclidean algorithm does. So here we have lol code. If you want, if that's your favorite language, you know, Julia is more mathy pseudocode. Python is a bit more CS pseudocode. That's probably true. Well, okay. I suggest remove C++. There's C already. Maybe. Oh, okay. Then I don't know. Like after basically there was a big issue that came up. It was number 114. It was a PR issue, I don't remember, where basically someone came in and they wanted to update the code for C++. And I was like, this is great, but also like, I don't know. I feel like I did not like the direction of the code because, you know, when I write C++ code, it's usually like this. And quite frankly, because of the way that code was written, even though it did use all of the new like things with C and C++, I found it was very difficult to read. And as someone who was trying to teach the algorithm, I felt the code was holding me back and blah, blah, blah. The point was, it ended up being a huge debate. And after that, I just said, look, I'm not dealing with C++ in the algorithm archive. Other people can. They do whatever the heck they want to do with C++ in the algorithm archive. But for me in particular, I'm not gonna worry about it. Just we'll let it be what it is. We just opened an issue for lol code, fix required. Oh no. Yeah, feel free to take a look. Remove C or just have C++. I don't know. How have you been talking about languages for several minutes without someone saying R? To be fair, we don't have very few R implementations. If you want to start implementing stuff in R, you and a buddy get together, implement something in R, review in R, that's totally fine. I genuinely we don't have very many people in R or in Java. These are two languages that are super well used, but for some reason, we just don't have very, very many people that are engaging with this community using those languages. Remembering the issue number? Yeah, it was a big issue. Removing C is worse idea than removing C++. There's too much byte shedding in C++. C++ is fine when you write it your way. Right, exactly. That's exactly the problem with C++. Number 917 is the lol code issue. Fair enough. Not R, the language beginning in R. Saying R. Oh, Rust. Rust is a language that people do actually implement stuff in for the algorithm archive. I know nothing about it. It's probably fine, but yeah, sure. C++ and C are different languages, especially with the new C++ standards. There are ways to write C that is not compatible with C++, and vice versa. Having both can help, right? So this is why, for me, I basically use C++ as C with additional features. It's basically the same code. I can switch over to C at pretty much any time. And the reason I do that is because I grew up in the world of scientific computing, where You're sending information back and forth to the GPU all the time. You're like, doing weird stuff that you actually care about, like, memory coalescence and like, this type of stuff. And I realize that C++ allows you to deal with that as well. But at the same time, those are not necessary to writing, parallel. It's not necessary for HPC programming is what it is. It's actually not necessary for most programming, but the fact is it's just quite out of the way for how people typically write that type of code. And so as such, I don't know, it's pretty much just C++ to me is C code with features. It is C code with like just little things here and there, and I like it for those features. STD vector is super nice. There's like random number generation is a bit easier in C++. There's stuff that is easier in C++ than it is in C, and I like it for that. Which is why I used to write C++ code instead of C code. But, if we're talking about writing correct C code, I don't know. I don't know. Right, most of my real-world acquaintances do this, basically C with a few extra things, right. Our programming languages rhymes with just in Rust. People don't write graph traversal in R. People don't write graph traversal in R. That's fair. Right. Anyway, like, so you can definitely argue that the whole, like, all languages and all algorithms is like, all algorithms in all languages is like an awful, like, thing to do. And I kind of agree with that from the standpoint of, we already have Rosetta code for that exact same purpose, but that's not exactly what we're doing here, right? Like, we're not looking for like the best C++ code. What we're looking for is the code that best exemplifies the algorithm written in C++, which is kind of different, right? And so for me, when I was looking at C++ code, I was like, hey, if I can't understand the code, then probably, if I, as someone who has written C++ code for probably 10 years, can't understand your C++ code, then probably it's not, you could write it a bit better so someone who is unfamiliar with the algorithm could at least, learn it with this code. The point is, I'm ranting. I'm ranting about C++, I'm ranting about MATLAB, I'm ranting about everything. And like Gawabunga said, understandability is key. That's what we focus on. That's what we care about. And if you argue with me and say that, the heavily templated, C++, 19 or whatever code, is actually more understandable for more C++ programmers, I would personally disagree, but I don't know anymore. I haven't done C++ code in a long time, so maybe you're right. Anyway, I'm ranting now. Let me do something really quick. I'm going to do this, and then I'm going to go to Discord, and I'm going to take a snapshot of a conversation that happened to me, and then I'm going to read it out here. I just don't want the guy's name to be available. Oh, this is going to be hard to make the guy's name not available, isn't it? Yeah, it's going to be quite hard. Can you download a conversation from Discord? How do I memorize the syntax for a function pointers in C? Okay. The simple answer is you don't. Okay, let me see. What do we have here? This. I'm just going to grab this because I just want to read this aloud. And I want to see if there's a problem with it. So let me go over here. You guys can't see what I'm doing, but give me just a GIMP. I think it's a screenshot. Capital S, screenshot 2021. What day is today? 11/7? Perfect. Okay, let me just blot out the guy's name, and then we'll take a look at it. Sure. There we go. Perfect. There. Wonderful. Okay. And also let me do this. Look, I'm not saying this is the best way. Like, there's probably better ways for me to have done this, but this is how I did it, and you guys are gonna have to deal with it. Okay. Do a screenshot and then redact in MS Paint. That's exactly what I did. Took a screenshot and then redacted it in GIMP. I missed something, or Unix equivalent. Just fix the low code issue. Oh, good. Cool. Great. That's another issue done. Actually, I think function pointer syntax. Oh, I only know function pointer syntax from C++, actually. In C++ it actually wasn't so bad. So I guess in C it's also not so bad. I genuinely don't know, if I'm honest. Okay, so let me read this guy because I don't I need to figure it out. I don't understand it. So it says further down the page, you have a graphic with blue and green and red curves, with the blue curve, where the blue curve is supposed to be analytic solution, with the other two versions of the forward Euler method with different time steps. As the analytic curve is near the horizontal at the left-hand side, and the other two should start horizontal for one time step and then curve up, but there should be a lag, so they should be to the right of the blue curve. The next graphic with oscillations also has similar problems because the red curve should overshoot more than the others at the start of the green curve. Okay, here is my stupid question. Okay, why does it start horizontal? Okay, let me reread this because I might not be understanding. Okay, let me read it one more time because I think I'm not understanding it. I have to use function pointers right now, so so function pointers were the reason I switched to Julia. Okay, not function pointers, but the GPU compilation pipeline with function pointers was why I switched to Julia. We had to do something where like people would implement, like basically we had something where people would write down a PDE in C++, and we solved it with the split operator method. But the issue was that in the creation, the compilation of this function, we essentially had a bunch of function pointers to like, add, subtract, multiply, and stuff like that. It basically just became a mess on the GPU was the issue. And doing it in Julia allowed us to leverage like native, or just leverage the already existing compilation pipeline. So it just made it a lot easier. That's what happened there. Okay. Also, like, I'm a bit confused. Do you not use function pointers? Am I the weird one here? I don't know. So let me do file. I'm gonna save. Just file export as I'm just gonna put in pictures, I guess. Stream. Oh, there's me. And we're just gonna do thing to look at. .png export. Let's go here. Discard changes. CD into pictures, stream, and then Mirage thing to look at. Perfect. All right, just so I can zoom in a bit more. All right, I'm gonna read this because I'm confused and I don't understand what they're saying. All right, so low-level programming homework with C11 standards. So yes, functional pointers. Right. It's been replaced by std function or lambda in C++. Has it? Because okay, fair enough. I maybe we were using. I mean, at the time we were using CUDA. So maybe there was a limitation to only using C++11 or something. I don't know. At the same time, more than likely, I just grabbed whatever I could and just used it. I learned a lot when I was writing that code. And I'm not going to say the way I implemented it was the best. I'm just saying that I found that it was easier to use Julia for this thing than it was for me to use C++. That's what I'm trying to say. C++ function pointer syntax is indeed messy, even in C++11. You can't use some functionalities with CUDA, std function, maybe one of them. Oh, right. No, actually, in fact, that was the case. Right. Because I think I tried to use std function. I actually spent like an entire week rewriting the code so I could use that, and it failed. And I was like super pissed off because like, basically everything was working on the CPU variant of the code, and I was like, great, this works fine. Everything's working great. Wonderful. We have a perfect working minimum example of everything. And then I tried to work it on CUDA. It just failed. I was like, crap. I was really pissed off. Okay. Let me read this comment again. Further down the page, you have a graphic with blue, green, and red curves, with the blue curve supposed to be the analytic solution and the other two versions of the forward Euler method with different time steps. So what they're talking about is this curve right here. Can I just view the image? Copy, save image? Sure, save image. We're going to do error.png. It's going to be under pictures. Pictures stream. Sure. Save it there. Wonderful. All right. This is the image that they're talking about. So just screw it. Just stop it. Why do I suck at using any GUIs? Like, genuinely speaking, I can't use a single GUI. Okay. I should be able to. Okay. Yep. Let me just go over here again. Here's the thing to look at. And let me take a look at that curve. So They are talking about, hello, that's me. Hello, no. Okay, this curve. They're talking about this curve in here. Okay. And they're saying, sorry, it's taking me a second to figure this out. They are saying that the blue curve is our analytic curve, the green curve is with a time step of 0.5, and the red curve is with the time step of 1. My argument with this image was that as you lower the time step, you get closer to the analytic solution. That was the whole point of the of this figure. Admittedly, it's a bad figure. Like there's no lines anywhere. I'm redoing the figure. That's the point of this visualization. Now, what they're saying is that the green and the red curve should be under the blue curve, and that is because at the very first time step, the blue curve should go up, the analytic curve should go up, but the red and green curves should not. Which bugs me because the Euler method is genuinely just, unless I'm in, okay, so why is that the case then? This is what I'm trying to figure out. All right, SD function is a dynamic object. It can't work on the GPU, which has a lot of tricks. Yeah, right. I learned that after I tried the function pointer stuff. You asked him to explain it further. Right. So the reason I'm confused by this is that, why does it start horizontal? Oh, I see why it starts horizontal. Right. It's because I wrote this chapter differently. Correct. Yeah. Right. Because I wrote this chapter with the assumption that you start with a PDE at hand. Whereas most people write this with the assumption that they're doing the derivatives on the fly. That's why. No offense, but do you actually like the way your UI looks? I really do like the way my UI looks. Why? Sorry. I genuinely like my, like almost everything about this setup. I'm sorry that it bugs you. Since you take f of x naught plus f prime of x plus times delta, if f of x naught is 0, then you have a lag. Right. If f of x naught plus f prime of x naught times delta. Correct. But the thing is here, I changed it. So the thing is here, we have the analytical solution. We have a PDE to solve, right? So we have the first order derivative already. And because of that, we have, we don't have to, we're not doing a derivative on the fly, right? That's the difference. So that's what's happening here. Now, again, you can argue that that's not an idiomatic implementation of the Euler method. And I think the actual solution here is to just take down the Euler method for a second. And just redo it again when we do the Runge-Kutta methods. I think that might be what we do. Yeah, so maybe that's what I do. Maybe I take down the Euler methods for now, because honestly, it's very clear that people reading this method did not understand what I was trying to do with it, because at the time what I was trying to do was explain things from a more analytical perspective. No, I'm not blaming Euler. I'm not blaming Euler at all, just for the record. What I'm trying to say is that the way that I wrote this chapter is very misleading, right? And I did it this way because from a physicist's point of view, I can't even say the word physicist, it made sense. But I think the truth is that for most people, they're probably coming from Euler, already learning it in class, in which case, this is quite different. Again, it's because we're not doing the derivative on the fly. We have, we already have the equation at hand, in which case it's totally fine. Okay, so what do we have here? Okay, so that's what I'm actually going to do. I'm actually just going to remove the Euler chapter for now. That's what I'm going to do, because I'm planning to do more in just a second. We're going to implement the Runge-Kutta method like next month. So I'm just going to take it off and then go from there. Who works with PDE though? Pretty much everyone is given a PDE to start, right? And so because of that, it makes sense to start with the PDE, do the analytical extrapolation, which is what this was. But I think the problem was because I was doing the analytical extrapolation, and I wrote code with it. It's just bad. Like, it's just a bad chapter. I need to get rid of it. That's what I'm going to do. So I think I'm just going to remove the chapter for the Euler method. And then we're going to come back in like a month and just rewrite it with the Runge-Kutta methods anyway. Screw it. That's what we're going to do, because it's going to be rewritten in a month. So fine. Gawabunga was being a bit facetious there. Um, let's agree to disagree about what we perceive as visually pleasing. So, okay, just for the record, Fabus, I'm not going to, you're obviously attacking my setup, and there is some truth to that, right? Like this setup was created when I was 14. I installed Arch Linux for the first time, and that's what I did. I installed Arch Linux for the first time, and quite frankly, I was mesmerized. I loved basically everything to do with simplicity at the time. And so I created an open box layout that was literally 3 colors, black, white, and gray. And I've been using that for literally 14 years. Now, you could definitely argue that I should change and I should get with the times and stuff like that. But I really like the setup. Like I genuinely have tried like changing, Windows managers. I've tried changing desktop environments. I've used Mac for a bit, which I think is close. It's not bad. But at the end of the day, I keep going back to this setup and I just love it. I genuinely love it. You can use that. I'm not blaming you. Oh, for the record, I didn't think you were blaming me. I thought you were judging me. Exactly what Gawabunga said below. Like, I just want to say that I understand that everyone has a different aesthetic preference as to what they like. I personally really like this setup, and I understand if you don't. For example, you might really like KDE, or you might really like GNOME, or you might like Windows, or Mac, or whatever. Totally fine. But this is perfect for me. I really like it. Have you tried a different font? I have, but I actually really like this font as well. I'm a big fan of bitmap fonts. And so for me, I tried switching to some of the vectorized fonts and stuff. And in fact, maybe I could try that again later. But something about bitmap fonts, I just really like. And the only problem I have with this font is that it's sometimes difficult to distinguish between a comma and a period. That's the only problem I have with this font. Other than that, I really like it. And actually, like I said before on stream, I actually lowered the resolution of my computer so that I could use bitmap fonts a bit longer until eventually, I have to get a monitor of super high resolution. But for now, I like them. I'm sorry, a lot of people don't. Totally fine. I really don't care. I don't use syntax highlighting. If you're gonna sit here and argue that, if you're gonna sit here and argue anything, argue about syntax highlighting, screw it. There's so many things to argue about. Okay, but you guys have convinced me. I think the actual solution here is to take down the Euler method. There's just a lot wrong with it. So let me go ahead and do that right now and just put in the PR and just say, look, I'm going to be redoing this chapter anyway in the near future. What do you mean changing the screen resolution? So if you have a bitmap font instead of a vectorized font, this means that every single character in the font, if you have a high resolution image, like a 4K screen, then your bitmap font doesn't scale with the screen size. So having a lower resolution screen means that your font appears bigger, and therefore you can see it better on stream. The main reason I use a bitmap font is that at this size, it looks good. At this size, it also looks good. And the main problem I have with the vectorized fonts and stuff is that when I try to put it at a font size that I actually like, which is usually this size, it looks bad when I put it at this size. So it just doesn't scale super well. And having something that's definitely looks okay at all the different resolutions is nice, for me in particular, right? Anyway, now we're talking about fonts. We can talk about everything. 05620, thank you so much for following, really appreciate it. Okay, you guys are right. I'm going to remove the Euler method chapter. Or do you mean it doesn't scale? How come it doesn't scale? Or do you mean pixel perfect? So the whole point in the vectorized fonts, and maybe I'm wrong, let me just double check to make sure I'm not, it is a vectorized font, is that it is allowed to scale from any resolution. So you could technically have it, so you can have a really small or really big version. So it scales from one size to the next. That's the point. But the problem with that is that pretty much all the time when I try to put the font at this size, it just looks blurry to me. So for example, let me open Sakura, which is the I'm so sorry. I for some reason have a weird color. My colors are weird for some reason. So let me do options. Wait a second, options, and we're going to select font, and we're going to make it super small. Right, so we're going to make it size 8, select. Okay, so this size, maybe size 10 is something. So we're going to do select font, size 10, let's try that, select. maybe a bit bigger. 1 second. Options, select font again, maybe 12 or something select. Okay, so yeah, this is kind of about the right size, I think. It's a little bit different. And this is actually kind of fine. I think I'm happy enough with that. See you, Nick. Have a wonderful evening. But like at some scale, like it just looks funny, right? And that's because the scale is all done automatically. Whereas with bitmap fonts, you have a specific size that it grows to. So like, for example, this can be either unreadable, tiny, small, medium, large, huge, enormous, or default, which is, I don't remember what the size is for default, but the point is, at all of these sizes, I can guarantee that it looks decent, right? And now, honestly, this doesn't look bad. I will probably switch to this font. I will probably switch. Okay, that's not what I mean to do. How do I unfull screen this? F11? I'll probably switch to this font because like I do like the Sakura terminal. And I don't mind this. I think this is actually quite nice. Admittedly, right, probably purple was not the right color, but I can do the same setup over here. You know, I can do another terminal. Is it S? Yeah, that's what it is. So I can do another terminal. What is it? This? Control Shift? There it is. So I can do another terminal. I can do the same setup here. I can move this over here. You know, perfect. I just ignore the purple for a second. You know, fine. Like this is gonna work just fine. Maybe I'll make it one bigger or something. Yeah, something like this is fine, right? So I can do this. It's not a big deal. I can have the same setup. It's just that I don't know. For now, I like the bitmap fonts. In addition, you know, it allows me to use Xterm, and I do quite like Xterm because if we do CD pictures, and then LS here, and I'm gonna CD into stream stuff, and then I just do L6. I can like directly output the pictures in my terminal, which is, I don't know, it's kind of nice. I like it. So, what is it? It's image to Sixel, and then we can look at thing to look at. So here's the image that we had earlier, and you just have it directly in the terminal, which is quite nice. I don't know, I like it. Anyway, I'm sorry, I'm rambling so much about my setup, and no one cares. Like it doesn't matter. Yeah, I can change. Sixel graphics takes me back to the 90s. Man, I really wanted Sixel graphics to be like the next big thing, but it just, it just never caught on. Okay, here's what I'm going to do. I'm going to create a new branch here, and I'm just going to remove the Euler methods and just say, look, there's actually a lot wrong with the chapter, and explain what the thing is, what's wrong in the PR, and I'm just going to remove it, and then we're going to come back in and do it better with Rangakata. All right, cd back another directory, git checkout. Master. All right, git pull upstream master. It's just disappointing is what it is. Okay, so yeah, these are the renaming stuff that we just did. So git checkout -b, and we're gonna do Euler removal. All right, I'm an idiot. Control C here. Now let's do git rm forward Euler method. Sure. Star. I'm an idiot. Remove that with an R. There we go. The following file has, yeah, it's fine. -R. Okay. -F. Okay. Will it be part of Rangakata or will it stay a separate chapter? I will have a separate chapter for Euler method as well. Because the Euler method also comes with the backward Euler method, and you probably Crank-Nicholson and all that kind of stuff that builds off of the Euler method. So it's super important to have like a separate chapter related to it. But it will come with the Rangakata stuff because when you think about Euler method, it's super hard to distinguish. Like you always talk about Euler method when in the like brain space of Rangakata, like it's the first step of a Rangakata method. So. You can still have that on other terminals. Kitty does it, but with other system, right? Yeah, like there was a time like I really wanted Sixel to be like, you know, a huge thing. I really like Sixel graphics. It's super nice. In fact, I was thinking about redoing all of my videos to be on a 24 by 80 terminal or whatever. And like just all of them being via Sixel graphics. So if you wanted to, you didn't have to watch them on YouTube. You could just pull them down from online and just play them. but I never did that. And I'm probably not going to do that. Okay, so let's go ahead and do VI back into the summary.md, go to the Euler, Euler here. Differential equation solvers. In fact, we should probably also remove the differential equation solvers here. Let me see what's actually in that chapter. VI differential equation solvers. Oh, here, there's like nothing in that chapter. Let's go ahead and remove it as well. And we'll update it later. Let's go and do git rm -r differential equations. Sure. Sure. And now let's go into VI summary.md differential equations. DD there. Rank quit. Sounds neat. Yeah, I'm looking forward to doing it, but it's yeah, it's just I'm a bit bummed right now because I have to remove the chapter. I hate doing this, like because I also hate rewriting stuff, but it's fine. This one does need to be rewritten. I'm just gonna take it off. Okay. Because again, it is misleading. I think the problem was I tried to describe it in an analytical form, and then I provided code, which is clearly in a discrete form, and it's just the code was also bad because like you had to hard code the derivative into the code itself when you probably should have taken function pointers instead or something like this. There's so many issues with it, and so I'm like, all right, screw it. There's just a lot of issues with this. I still have it on a side branch. We're gonna work on it later, but for now, I think it's really important just to get rid of it for now. Okay, git status, git add back to summary, git commit -m, removing Euler and adjacent chapters. All right, git push, origin master. What am I doing? Origin master. What is it? Euler remover. I'm an idiot. Perfect. Okay, let's go over here and let's do it. All right, go to GitHub, go to the algorithm archive. Okay, and the next thing we're going to do is compare and pull requests. I'm just going to talk about the issues here. One second, I have decided. One second, Euler chapter. This is because of the following reasons. So one, the chapter was not technically wrong, but it was very misleading as to how people truly implement Euler methods in practice. Namely, let's see. Namely, people don't have the like analytical expression to look at. Well, okay, let's just say that. I'll leave it at that. I mean, I can go further into that if people ask, but the main thing is like, usually you have some sort of like derivative that you're applying, and hence why people were confused that our error metric was our error terms. Why the analytical solution was below the other two solutions. Like people were confused about that. It is very clear if you read the chapter as to why that's the case. But also that's not how people implement Euler method. And I think it wasn't fair to describe it in that way. What I will say is, I think starting from the Taylor series makes sense from a physical point of view, but not mathematically. All right, next up, what am I going to do next? So the other issue here is the code basically had the derivatives hard-coded in, which is, again, not how people implemented it. It's not how people often implement it. I could rework the chapter but I would, let's see, I could rework the chapter to keep the code. I don't know if I said thanks for following me, Gavin Beachy, but thanks for following. But I would need another chapter to link it to RK, backwards Euler, or other methods. So I think a full rework is needed, and is on the table in a few weeks, when I am working on my next project. All right, sorry again. Some of the core issues are some of the core issues with the algorithm archive have just been because I haven't been able to teach things properly. I haven't been, how do I read this? I have not been, yeah, because I haven't been able to teach. Right. Sorry again. All right. Well, I'll leave that out. I'll just leave it as is. Create pull request. All right. Let's do files checked. Oh, it's just such a pain. Removing 1,000 lines from the algorithm archive just because I don't see how to salvage it right now. Obviously, people can have discussions under the they can obviously have discussions under the PR if they want, but I think it's actually just best to remove the chapters. Again, we have Runkakutta coming up in the near future. I can just talk about it then. In fact, I'm going to mention that here. Edit. So right now, right now, I will, let's see, when I'm working on the next project, for this, which will involve, yeah, okay, good. Let's go ahead and do update comment. Okay, kind of depressing, and a little bit disappointing, but hey, you know, like, sometimes it's just how it is. Okay, what do we have here? Let's go to pull requests. Fix 917, Fabus, hey, thanks for that. I don't know if I can actually do the review right now. Oh, is that it? If that's it, what is the difference? Wait, what did you do? Are you still in chat? I don't know if you're still in chat, but num2 are EI versus I? What is the difference there? Oh, that must have just been a typo. Yeah, that must have just been a typo in the original code. Let me get some water. It was just a typo, right? If so, I'm happy to review it and just approve it. Yeah, okay. I'll just approve it and we'll merge that guy in. Review changes, approve. Yep. This looks like just a typo. Happy to merge this in. All right, submit review. All right. What was the issue? Approve and run? First time contributors need to maintain and approve. Yep. Perfect. If you want, you know, it's up to you, but if you want to put yourself in the contributors.md file, feel free to do so. I know it's like a one letter change, but if you want to do that, feel free. So yeah, the way it works is that, you know, we have a, here, contributors. Where's contributing? Oh, this must be for, oh, this how to contribute. Then we have contributors. We need to clean this up. Like, we're trying to clean this up. But it's just a list of all the people who have contributed. The reason we keep a separate list as opposed to the GitHub list is because it's just, the reason we have a separate list is because some people do not actually want to be like acknowledged for the work that they did, and some people do. And so, you know, we could just say, hey, here are all the people that helped, and there's like 105 contributors. But some people are like, you know, I don't want people to associate me like I don't want to get recognition from this project, you know, and so we have a separate list. I realize it's just one line change, but I just want to make that very clear. I don't think one character contribution is worthy to be listed. That's also fair. In that case, let this build, and then once it's built, we can go ahead and merge it in. Okay, looks like I can squash and merge. Let's go ahead and do it. I don't think I even have to squash. No, I don't, but screw it. Squash and merge anyway. All right, done and done. Okay, so we got two pull requests and one pull request created. Again, I'm not a super big fan of like removing the Euler chapter, but like it just has to be done. Like that's just, it's not a good chapter, and we need to just fix it. And so that's going to take some time, and we'll do that on the side. Okay. Man, I need just a quick break after that one. That was just, I mean, I'm not saying that it was like, you know, I'm just like, you know, like you're kind of on a high. You're like, I can fix this, I can do this, and then it's like, no, actually, it's probably best just to remove and start from scratch again. There's one other thing I have to do, which I'm going to do right now, but I can't show you guys as I do it, and that I'm actually going to remove my Euler method YouTube video as well, just because it points to a chapter that doesn't exist, and I don't like that. So let me go ahead and fix that as well, and then I'll be back in just a second. Content. Where are we? Euler method. Oh, that has such a good thumbnail as well. Anyway, I'm just gonna make it unlisted. Save. Okay. I should probably just remove most of my content. Ah, man. Okay, so like I'm getting to the point with my YouTube channel now where it's just like I hate all my videos. So like last year I was like, oh man, these are I was happy with the videos that I had, and now I'm like, actually, I should probably just get rid of all of them. That's just what happens, you know. That's how you know, like, you know, like there was a long time ago that I had like a fundamentally different YouTube channel, you know, like it had, you know, hundreds of videos, honestly. I just removed all of them because I thought they were all crap. And there's certain videos I think I'll keep on my channel, but I think a lot of them, I don't know, a lot of them I think I'm going to get rid of. Okay, so let me go from here. So let me do pull requests, and there are a bunch of chapters at the very end that I want to start doing reviews for. Let's go back here to 3. The very last one is a PID, cryptography chapter, insertion sort chapter. Okay, let's see what I want to do here. I think this one isn't actually a chapter. So if we go to the files changed, I think, oh no, it is actually a chapter. Right, okay. As Linkin Park said, I hate my rhymes, but I hate everyone else's more. Yeah, I mean, as far as the YouTube content is concerned, it is one of those things that shouldn't take up a lot of my mind share, but it takes up a lot of my mind share right now. And the reason it's taking up so much of my mind share is because I'm not putting content out, and I don't like the content that I have out. So it's just like, I know what I need to do to fix it, but it's hard to put stuff out when you're like in that mode where like you kind of feel like you don't know what to put out because you're afraid. Like every time you put out a video, every time I put out a video, you know, I lose 100 subs. Like every time I do a video, I lose about 100 subscribers. Fine, fair enough. You know, I can't really do much about that. But you know, it's something that happens, and you know, it's just a little bit of deactivation energy, you could say. You know, quality is better than quantity. I do agree with that statement. And I think that some of the videos I put out are particularly high quality. Like for example, YouTube. Let me just go there right now. Let me go to my channel. Your channel. Videos. Okay, so I think the videos that are super high quality, I think all the stuff that I put out this year is pretty high quality. I think actually these videos are also good, and these videos are good as well. Good, not so good, but it's not meant to be. This one could be better, but I think it's fine. This one's good. This one's not super good. This one could be better. This one could be better. This one could be better. But these are all me trying to figure out how to make algorithm archive videos good. And so like, I'm kind of okay with leaving them there. Then we have this stuff. And I think actually all of these videos are quite good. So I think the early stuff was good. The middle stuff was kind of maybe not so good. And I think this stuff's pretty good as well. Okay, so if you fall in the middle of the forest, do you really fall? Oops, that was an accident. Let me go here. Let me go to Discord. Sure, whatever. Okay. Ooh, what happened there? 1 second. Just for Pete's sake. This is why you don't let your bunny unsupervised for a week with accessible unprotected wires. Oh no. Uh, Man, that sounds dangerous for the bunny. I feel really bad about that. Okay. So let's look at the chapters. Algorithm archive pull requests. As long as I fall silently. Well, you are a silent tree. I think that's the only way you can fall. Okay. Pull requests. I said I would get through the PID chapter first because this is the one that just, I don't know. I said I'd get through the PID chapter first. I have a lot of comments on this chapter, a lot of comments, and I have to read through it. So files changed. Oh, did I lose the review? Ah, dang it! It's been like a month since I did the last review, and I'm pretty sure I lost all of my reviewing comments. So, darn. Okay. The question is, what do I do? Let me start by just bringing it up to the current master, and I'll do that for all the chapters right now. Yeah, look, it's going to be tough. Getting these chapters in is going to be tough. Here's all the changes I made. Let's see. Theoretically, PID chapters. I made a lot of changes. What's your favorite programming language? Probably Julia at this stage. I use it for almost everything. Okay, so let me see. So Gathros has been kind of gone from the community for a while, and I'm just gonna be like, yo, let me update the branch first, and then after updating the branch, I'm gonna just ask him. I'm gonna be like, hey, look, I dragged my feet on this for a long time, like a super long time, and it's totally my fault. And I'm gonna take the blame for this. But if you're still up for it, I actually provided a bunch of changes here. Let's make it happen. What Windows Manager to use? I use OpenBox. If you're interested, feel free to go to the off-topic channel, and it's going to be under pinned messages right here. Here, I'll give you guys a link right now. There you go. So yeah, it's in the off-topic channel on Discord if you're interested in the theme. But outside of that, it's just stock OpenBox. Okay, so I'm gonna go in here and just say, I think there's just a lot of changes. Am I allowed to? Okay, so if you have a PR, can you make it so maintainers can push to that branch? There's a way to do that. Can I go here, edit? How to let maintainers push to a branch? Okay, that's the default setting. So I should be able to push to this branch, is what you're saying. Okay, in that case, what I might do is I might just do all the changes that I see, and just ask him beforehand. It's like, hey, do you mind if I just push to this branch? I actually don't know how to do that. But the PR creator needs to do that. Okay, so, okay, let's see what we need to do. So how does a PR maintainer allow that? Because this was written before probably that was a default setting. So allowing changes to pull request branch created from a fork. So what I might do is I might just say, hey, do you mind if I open up a new PR, or can you enable the settings for me to push to that? Maybe I just try to push to it really quick and see what I can do. Yeah, let me try that. Yeah, so let's bring it up to master, let this build, and then I will try to see if I can push to this branch or not. And then I'm just gonna ask, hey, would you mind if I, if I push to this and I fix it up, right? In fact, I'm gonna do that right here. At Gathros, look, it's been years. I know I really dropped the ball on chapter reviews, but I am making it a priority now, and technically, and I promise that your chapter would be the first one in. Would you mind either one helping me working on this, with this PR, or two, allowing me to either push this branch or create a separate PR from this one with changes, with my own changes. Let's see, continue with the PR or allowing me to either allowing me to push this branch or create a separate PR from this one. Obviously, if I need to create a second PR, I will squash the commits. You will still be in the Git history. Okay. Good. I think that's probably fine. I'm probably going to remove look because that sounds a bit, I don't know, a bit angry, and I don't want to sound angry. Okay. It's been years. I really dropped the ball on chapter reviews, but I'm making it a priority now, and I promise you that your chapter will be the first one in. So would you mind either one, continuing with the PR, or two, allowing me to either push this branch or create a separate PR from this one with my own changes? Obviously, if I need to create a second PR, you will still be in the Git history, and I'm going to say here, if I don't get a response, I will go ahead and start with 2. Okay, I'm going to comment there. The next one I also want to take a look at right now is the cryptography chapter. This one was basically already done as well. So I'm just going to kind of bring this up to the current master just to make sure there's no issues with it. And then we're going to just get it done. Yeah. We have to resolve conflicts. That's fine. Summary.md also needs to be resolved. That's totally fine. Let me just go ahead and do that now. It's not going to be a big issue. So Bjorn is already in there, so we can just remove these. Perfect. Master. How is there a master down there? What's going on there? Why is it just a random... Okay. Well, let's just remove that then. Does that mean in the current contributors.md file, like something happened and there's... All right, let's just mark that as resolved. And then this one is going to be, what's the conflict? The conflict is down here. Add cryptography, totally fine. Oh, Control Z. Okay, there, here. I think I screwed up with the master thing. Let me go ahead and fix the contributors.md file then here. This one should be also good to go. All right, let's mark as resolved, commit merge. And then it was the end of the two-way diff, change it versus, oh, okay, good. So that wasn't on me. That was, okay, good. The next thing I'm going to do is just bring this up to the current master, and I'm just going to say the same thing with the previous PR. I'm really trying to get these chapters in. I realize it's been a while, but like, look, we need to get chapters in. So merging is blocked, one change requested. Oh, I'm the one that requested the changes. Oh, okay. So is everything up? Is everything good then? Oh, okay. I'm going to mention this and say to lict, if I remember correctly, similar to, what was the other one I just mentioned on 346, I am making chapters a priority. Would you mind either, let me just grab the same comment and just, well, okay, either one, helping me with this PR, or two, allowing me to work on this this PR either here by pushing to it or creating a separate PR. entirely. If I don't get a response, I will assume 2. All right. Comment. Okay. Now I have said that I will allow them to have time to like respond and stuff, and I think it is important that we allow them that time. So let me take a look at some other chapters and see what we can do here. And I'm just going to put the same comment on all the chapters and be like, hey, just let me know what your current availability is to work on this. So let's go down here, and I'm just going to make the comment on all these chapters. My goal is to get a new chapter in the algorithm archive every week, not written by me, Okay, so this one, okay, so I'm going to be honest. I removed the sorting and searching chapters because, quite frankly, pretty much anyone can do a sorting and searching chapter, and I didn't feel like it was... I felt like there should be a reason for them to be in the algorithm archive, and it should be like, reasonably well written and understandable, blah, blah, blah. Like we have to outdo other implementations. Yeah. So let me think about what we're going to do about insertion sort chapter and just say, I'm not sure what to do with this PR, but I am doing what I can to, yeah, so I'm going to mention here and just say, honestly, I'm not sure what to do with this PR, but I'm going to make the claim. I'm going to talk about why we actually remove sorting and searching from the algorithm archive. Jay Hashwat, thank you so much for following. Really appreciate it. I'm actually not sure to do with this PR. On the one hand, I think I am happy to add sorting and searching chapters so long as they are community contributed. Right. As long as they're community contributed, I think I'm probably fine. So yeah, we'll leave it that way. So I'll say, yeah, in a sense, that means this PR is still on the table if Guy Ponzer is willing to work. Is still willing to help with it after taking a few years to get back to them. All right, there we go. And let me see if there's any other chapters that have been submitted. I guess I can already update it to the current master. I feel like I kind of want to, but it's not as dire to do. Yeah, okay, I'll wait. Okay, let's go up here and see if there's any other chapters that we are going to try to tackle. Here we go to Algorithm Archive, go to pull requests. And let me just see if there's chapter in here. Chapter. Okay, removing Euler adjacent chapter, citation.cff, quick sort chapter, JavaScript added. Right, so this is another chapter that we have to look at. Euclidean proof, complexity notation, graph algorithms chapter, that's another good one. Explanation. Oh, okay, yes, that's still for that one. Edit complexity notation number 352. We have to update this as well, Euclidean proof. Okay, there is a lot of stuff to update. So let's go here to the quick sort chapter. Let's go to the files changed. Right. Okay, screw it. We'll just say, okay. How long ago was this? This was conversation, October 16, 2020. I realize it's been a year. But we are now willing to merge community chapters into the algorithm archive. So we can work on this. Let's see. So we can work on this together if you're willing. 1 second. Wait. What's going on? Chapter update. No, okay, perfect. Sorry, there was something going wrong with my audio down there. So we can work on this if you are still willing to help. All right, comment on that one. And then finally, the graph chapter in here. Theory is Jinkstra's algorithm, which actually I've never known how to pronounce it. I'm so sorry about that. Okay. This is actually fine, reasonably okay. You know, I would like some visuals in here as well. And I'll just kind of say what the visuals are. But, you know, we'll get in. Sorry about that. Okay, so finally, this is the last one. So let's go to conversation. And here we're going to say, okay, been a while. We're able to do community contributions now. Yep. Like Emra said, we are able to merge community chapters now. But let's see. So we're able to merge community chapters now. If you are still willing to help, I am really sorry about taking so long with this. Let's just go ahead and comment on there. Okay, good. We're getting there. Like, I mean, this has to happen. I knew it had to happen years ago. It's just, you know, basically when the PhD got really intense, it was very difficult to just balance everything. And I had so many things I wanted to get done and blah, just nothing happened. So this is my, you know, attempt to fix that. If people don't get back to me, I'll start working on the PID chapter and then the cryptography chapter. I'll let other people work on the sorting and the graph traversal chapters because frankly, they're probably going to be better at it than I will be. Because like, yeah, I mean, obviously A-star, Jinkstra's algorithm, all this kind of stuff, like fine. I know of them. I know them okay. But like, I'm sure other people can probably talk about them better. What I'm best served doing there is asking for like key visualizations and stuff that, you know, might be Dijkstra. Oh, thanks for that, Amras. Sorry. Also, I don't know why the automod took that, but I will allow that. Thanks. Appreciate that. That's me not knowing how to pronounce it because I've only read it in text. Okay, so yeah, good. I think then maybe we've talked to everyone. We've got a few PRs done. Use the star format for Fortran read statements. Cookie code enclosure doesn't run. Okay, this one. What is this one? I see that there have been some Fortran code submitted that Fortran is not available as an option on the site. Looking at the code in Interactive Euclidean, I suggest read. What do we have here? Stovethag85, thank you so much for following. Really appreciate it. Hey, Licht, how are you? Oh, hey, we were just talking about your PR that was submitted years ago, and it was me being a complete idiot not getting to it. Replaced by this, which will work even if the user enters two numbers on the same line before printing enter. Yeah, it should be. Why are we not using the Fortran owl here? Let's go here. Yeah, why aren't we? I'm happy with this change. Yeah, I'm not sure what I mean by not available on the site. Right now, there's only one chapter that has Fortran code. Is Fortran, wait, not available as an option on the site. Yeah, so we only have Fortran, yes. So like Shadow Michio said, we only have Fortran code when it is submitted by community members. Let me see, there might be another PR with Fortran in it. Let me go ahead and take a look. 1 second. This man can read Fortran. Man, I love Fortran. Fortran, I'd be surprised. Oh, Gaussian elimination in Fortran 90. There's this one, but I think I asked for some changes. What happened with this one? Oh, no. Right, Dapate was having issues with this one. So I'll go ahead and link this PR as well, 638. Here. Oh no, where was that? This one? Where is it? The only other PR Fortran PR is this one, 638. I am a big fan of Fortran. So I would be happy to see more. Last thing I'm going to say here, I think it is 638, right? 638. Yeah. If you want to create a PR about the change, this change, feel free to do so. And it will be quickly merged, I think. Okay, let's go here. Comment. What do we have here? I have been talked to. Yeah, how have you been? This man can read Fortran. It's pronounced Dijkstra? Really? Sorry, I was using Wikipedia's pronunciation. That would be like hey, but it's hi. So here's, I don't know. I genuinely don't know. I'm sorry, guys. Like, I've mentioned it a lot of times. I'm fundamentally gimped by the fact that I essentially was raised in scientific computing. And so there's a lot of like algorithms and methods that I've only really read about and never been formally taught. And the graph traversal methods are some of them. Like any graph methods, I kind of taught myself, And so I didn't have a teacher tell me how to pronounce this type of stuff, Amorous was correct. I don't know why I said there. That was stupid. Anyway. Okay, let me think about what we're going to do next. So, also, let me try something really quick. Let me go over here. Okay, so I want to see if I can actually have my email up on the side here. I know this sounds really, really dumb. Just hear me out. Can I do this? No, that's not going to work. I'm trying to figure out how to allocate my side screen so I can have my email up on the side in the case that like people do like GitHub notifications and I don't want Stream to see that. I can probably do this. Maybe, okay, that's just not gonna work. I don't know how to do this. I create an open tab. Let me do, I also don't have notifications up. Sorry about that. I just had the Twitch notifications up. The English pronunciation is technically not correct indeed. Yeah, fair enough. Let's do this guy, dashboard, I guess. Recent events, sure. Okay, wonderful. I don't know why that was useful in any way, shape, or form. What else am I gonna do? I can probably just open up Gmail, and that's probably what I'll do on my side screen. I usually don't like using Gmail. I like using Thunderbird, but it's fine. It'll just be up as a side thing. Gmail doesn't send like, it doesn't send like notifications, does it? Maybe it does. All right, let me see if anything came into my inbox. What? I know something should have come into my inbox. Social promotion. I don't know how. I genuinely don't know how Gmail works. Here. Oh, algorithm archive stuff. Okay, fine. I think it's totally fine. Okay. Sorry, that was kind of a waste of time. I do apologize for that. Let me find whatever there. Perfect. Let me go to the PR I was just on. Okay, so for those of you guys who may not know, Lixt is like one of the, I mean, not like original developers of the algorithm archive, but they've been here a long time. And so a long time ago, he created a chapter that was reasonably well written, and I think was almost ready to be merged in for the cryptography chapter in here. And I think you just responded to it. Perfect. Okay, let's see what we got to do. And let's figure out what we need to do to get this chapter in. I think most of the conversations have been resolved. I don't mind helping, but you can also feel free to push the PR if you see fit. Okay, so let's see what actually needs to be done. Let's see. I think, so the thing about this particular PR that got me when I was looking at it initially is I don't think there was actually any code available with this chapter. And so what ended up happening was I was like, can we actually, can we actually merge this in? So what I'm probably going to do is I will probably, I technically told Gathros that he could be first dibs to the first chapter that's in the algorithm archive, which was another reason I was dragging my foot on this PR. But like, honestly, it's just been a bunch of excuses. So this is more of an intro for the cryptography chapters. That was the whole point. Now, if you want to keep going with cryptography chapters and implement more, feel free to do so. I think, I think I had a few changes in here. So let's see, what did I say here? Uh, um, yeah, okay, so my first bit was I just wanted a bit more exposition at the start. Um, then sure, I just made some changes in here. What I might do is just push those directly to the chapter, because I think after those changes were made, I think I was happy to merge it. I was like, yep, that's it. Um, yeah, and I'm not saying they have to be word for word, but basically, I asked for additional information. I think anytime that like I felt, I think I asked for additional information anytime I felt like I was just missing something. Um, I think I might also like maybe some visuals or something, but we can talk about that later. So honestly, I think the only thing that has to happen are some changes, but I think maybe those have already happened. So let me just go ahead and pull this down locally and see what the changes are, and see if it's ready to go, because it might be, and maybe I haven't taken a look at it in a while. So let's go ahead and grab it locally and just see what it reads, or how it reads, and see if some of the changes have been made. If they haven't, that's also fine. Okay. So we're going to git branch. All right, git checkout master. And now we're just going to pull this guy locally. All right, not what I meant to do. Let's try to fix that. What was that? How did that happen? What? How did I get a list of everyone? Okay, let me clear that, because I didn't mean to like anonymize everybody. I apologize for that. But I genuinely don't know how that happened. So, okay, let's go here, grab this guy, and let's just go to the cryptography chapter. So we're going to go over here to Control D, and now we're going to run cd into projects, algorithm archive, npm run serve, and then this should just build. We'll have the cryptography chapter, and we can mess around with it. Yeah, again, guys, if you have any comments, questions, concerns, ideas, feel free to let me know. What I'm going to do is I'm actually going to take a look at this chapter, see what it's like, and then probably I'll close stream in like 20 minutes or so. That'll be about 3 hours streaming. I realize it says under stream that I've been streaming for 1 hour and 30 minutes, but we had some issue with audio-video desync, and I just kind of restarted stream in the middle there. So that's kind of why it's been like that. So let's go over here to the local host. Oh no, we're on the internet. Scramble. Fair enough, right? All right, let's D a bunch of these guys. Now let's go to the local host. All right, so the cryptography chapter should be at the bottom over here. Okay, that's Computus cryptography. Yeah, so I think these changes, let's go to the pull request, algorithm archive, here, whatever, GitHub over here. Okay, so this is what I'll do. I'll basically, if you're happy with the changes that I had in the pull request, I'll just go ahead and merge those guys in, and then I think everything's good to go from there. So let's do cryptography chapter here, and I'm going to say, okay, let me scroll down here, and I think I can directly push to this branch, right? How do I do that? How do I directly push to a branch? I know this sounds really dumb. Git branch. So do I just push? So like if I want to push to linked cryptography, how do I push to that branch? Do I just change a file and then I push to it directly? CD into cryptography, ls here, vi cryptography. Because I got lost in transit, the changes you mentioned should be implemented already. Okay, perfect. Let's just take a look. Cryptography.md. Let's go in here. If it sounds like they've been implemented, then we're good to go. It doesn't matter if the messenger is evil, because I remember I actually quite liked it. I just gave a lot of like expositional things. Let's see what we have here. Humans have. Yeah, let's do it. Let me read through it one more time, and let's just get this guy merged in then. Okay. Humans have almost always been interested in sending secret messages that only the sender and receiver understand. The reason for this is obvious. Secret messages should remain secret. The easiest way for this to happen is to talk behind closed doors, but that simply doesn't work if the sender and receiver are separated by a significant distance. In this case, they need to rely on a messenger or mailman to send the message. All right. For simplicity, let's assume that they are sending a written letter for the purpose of negotiating war tactics in ancient Greece or Rome. Obviously, the message can remain secret if both the sender and receiver also trust the message. However, what if the messenger is actually a spy? Hoo-hoo. What if the messenger is killed and the letter is stolen? What if, in an elaborate ruse, some third party slips into the messenger's tent in the dead of night and replaces a letter with another one entirely different? Oh no. this is quite good, is what I'm saying. I quite like this one. It's been a long time since I read this, though, so it's kind of new to me. These are all important questions cryptography addresses. The idea is simple. We procedurally scramble the message we are sending and only provide the unscrambled procedure to trusted parties. In this way, the message would seem like utter gobbledygook to anyone other than the sender and receiver. It doesn't matter if the message is evil. It doesn't matter if the messenger is evil. Two generals sound so much nicer like this. It doesn't matter if the messenger is evil. They cannot read the message anyway. In this way, the message would seem like utter gobbledygook to anyone other than the sender and receiver. It doesn't matter if the messenger is evil. It doesn't matter if the messenger is evil. Oh, right. It doesn't matter. Obviously, the one sending the message. I'm just an idiot. They cannot read the message anyway. It's also fine if the message is replaced, because then the receiver won't be able to properly decode the message and can just ask for another message to be sent, probably on another path with a different messenger. Unsurprisingly, a very early method of encryption was supposedly developed by Julius Caesar and called the Caesar cipher. Here, every character in the message is replaced by another character based on some predefined table or chart that only the sender and receiver have. The table is created by simply rotating the alphabet by spaces, where is chosen in a discussion between the sender and receiver. The table is created by simply rotating the alphabet by spaces, where something is missing here, where the amount by which you rotate is chosen in a discussion. That's fine. Let me just go ahead and mention that quickly. Again, these are small changes. I'm not going to change too much here. I think it's actually quite nice. By simply rotate. Oh, I see what's happening. I see exactly what's happening. Okay, we have to add the little math thing. Right. Because we're missing Greek characters. No, it's not on you. This is a problem with the math appearing in the chapter. Let me see if it's fixed now. By n spaces, where n is chosen. Perfect. So to fix this, we need to add this little caveat at the bottom. I'll go ahead and give you what you need to add in. Let me see if I can find it somewhere else. So let's go here, quit. Oh, I'm so excited to get this in. I'm unreasonably excited to get other chapters in the algorithm archive, actually. So we're going to cd back into, I don't know, tree traversal should do it. Perfect. Vi tree traversal.md, and it should be, where is it? It should be this guy. Perfect. Let's go over here. There might actually be something like that already in the chapter. I don't see it, but that's okay. The text of the chapter is licensed under this with attribution to lict. Sure. Code is licensed under the MIT license. There is no code, so we can probably remove that. But what we do need to add down here somewhere, it doesn't really matter where, so maybe I'll just add it here. Suggestion. All right, let's just add this here, and then I'll add an extra. All right, start review. Okay, and down here we can actually probably remove this guy. So we can remove the code examples because there is no code example here. So we can just suggestion. Perfect. Okay, add review comment. I might actually. We might actually want to remove one more line. That's okay. I'll just add that as a suggestion as well. What I might say here is was written by lict, and then I'm going to add another suggestion here. And edited by Leos. Well, no, it's fine. Let's just leave it there. That's fine. Yes, yeah, I think it's perfectly fine. But what I do want to do is remove this guy, delete, yes, and do this down here. Remove that. Here. Add review comment. Link to the GitHub profile. Yes, that's what we need. Perfect. Thank you. I knew we were missing something. Suggestion. Okay, and here we'll just add that. It shouldn't be hard. Licked, and then we want to do GitHub profile here. So let's find that GitHub profile. I guess I can find it just by going to the top. 1 second. Here, conversation, and then clicking 1 second over here. Perfect. Cryptography chapter, scroll down, and paste it there. All right, add review comment. Cool, we're getting there. We are definitely getting there. All right. Oh, that's all one line. Okay, let's change this. Edit. This guy. Under the, paste it. Update comment. Good, okay. Let's just keep reading, see if there's anything else that's missing. I don't think there is, but just double checking. Okay. N spaces where N is chosen in a discussion between the sender and receiver beforehand. It's certainly not the most complicated scheme out there, but is generally the first encryption scheme people come up with when trying to encode secret messages to one another. Should we have an image here? I mean, just because this is a long paragraph is all I'm trying to say. Is there an image later? It might be nice to have an image here. I'll leave that up to you. So let's do cryptography chapter, and I'm just going to mention that rabbit image, the one I accidentally went to. All right, let's go up here and just say, where are we? In the cryptographic, what do we have? Cryptographic systems are cornerstone. Nope, I'm further up than that. Cryptography, N. Where are we? I'll find you a nice image. If you can, that'd be great. It doesn't have to be like, it's just, it's something that's clearly, anything Creative Commons is fine. As long as we provide proper attribution, it's fine. So let's see, what do we have here? Caesar cipher. Even if you create the image, I could probably recreate it somewhere else. So I think here, I'm just going to say, might be nice to have an image. All right, or something. Add review comment. Hello, how are you? It's going okay. How are you doing? Okay, so let's keep reading. Cryptography chapter. Where were we? Here, every character in the message is replaced by another. Right. The table is created by simply rotating, or maybe not even an image. A table might do there. Or just a table, like image or table. Or just a markdown table. I think that'd be nice. Okay, yeah, I'll make you a nice image. Anything's fine. Like we're gonna get this in. I'm so certain we're gonna get this in. I've just been dragging my feet on this, and there's no reason for it. Like it's literally just my fault, and it doesn't fall on anyone else's shoulders, Okay, so what do we have here? Caesar cipher. But where was I? N chosen. Okay, here we are. But it's generally the first encryption scheme people come up with when trying to encode a secret message to one another. Honestly, I remember sending messages back and forth to friends in elementary school, but we would never provide the necessary table to decode the message. Instead, we would provide enough text that they could find the table themselves from context. If a bunch of elementary school kids can figure out how to break this encryption scheme, it cannot be too robust. In fact, it's interesting to see how the field of cryptography has grown since the Caesar cipher was developed. In cryptographic literature, there is always a sender, receiver, and eavesdropper. For some reason, beyond my own comprehension, these three people are always given the names Alice, Bob, and Charlie. True. These names are consistent even with quantum cryptography, so they're here to stay. Take a picture of the Caesar... Did you say salad? Caesar salad? In general, there are two different types of encryption, symmetric and asymmetric, both of which are described in the following sections. Cryptographic systems are a cornerstone to modern information technology and lie at the heart of everything from Wi-Fi to online banking. If an attacker manages to crack modern cryptographic algorithms, they would cause serious damage. For this reason, it's important to keep a few things in mind. One, maybe enumerate instead of list here would be nice. Yeah, slight change, just enumerate instead of a list. Lisp. Oh my gosh. Oh, I'm so sorry about that. Yeah, so just, I might do a slight change here to change this to 1, 2, and 3 instead. You don't have to take those suggestions. One, dot. Oh, hello. Why don't I just, what am I doing? These are all on different lines, right? Oh, no, that's fine. Let's go here. Why? I keep pressing the wrong button. Add review comment. We'll do the same here. Suggestion. Here we go. There, and just do 2. Add review comment. And then 3 down here. Suggestion. And grab this guy. There we go. And 3. What's crypto in that context? What is crypto in that context? You mean the salad context? Yeah, take a picture of the salad, Caesar or Eve. 1 second. Let's go over here. Let's keep reading. Because crypto has become such an advanced field, crypto systems should be analyzed by training. Actually, there's a few things wrong with that sentence. Let's work on that. So because cryptography, let's just edit this guy. Because cryptography has become such an advanced field, cryptography systems, cryptographic systems, should be analyzed by trained professionals and have to go under and be extensively tested and vetted. I'm going to change that just because my brain isn't. All right, update the comment there. Let's keep going. Kirchhoff's. Oh wait. Meaning whenever possible, we should use a widely accepted cryptography library instead of writing your own cipher. Okay. Right. So vetting like with animals. All right. So we're working on a online textbook called the Algorithm Archive, the Arcane Algorithm Archive. So the idea here is like, you go to the domain coloring chapter and it's just a description of how of the chapter, what's happening, and then you can switch between a bunch of different languages. Here, because it's a plotting chapter, we only have NuPlot and Python, but if you go to Barnsley-Fern, we have a bunch of different languages available that you can switch between. And so right now we're reviewing a kind of introduction to cryptography chapter that will hopefully allow us to write some cryptography chapters in the future. We should define crypto systems earlier, since it's the classical terminology. Yeah, if you want to add some additional stuff to this PR, feel free to do so. In fact, you're probably right in that. I'm right now. So wait, when you say crypto systems, I think this is the start of, like, we have a lot more here with symmetric and asymmetric. So I feel like this is maybe the right place to introduce it, but also feel free to mention it in the PR. We're getting to it. Okay. This next one, I'm just gonna change this. Okay, I'm a stickler, and I'm so sorry I'm a stickler. Okay, look, there's this guy that I wrote one of my first papers with. He was just, always angry about like the difference between an N dash and an M dash and how you have to use one and not the other and all this kind of stuff, and I get it. And I never wanted to be one of those people. And now I realize I'm one of those people, like it's turned into one of those things. Let's grab this paste it there. Did I miss a space? No, I don't think so. I'm going to modify this sentence just because it's not clear to me. This means that whenever possible, you should use a widely accepted cryptographic library instead of writing your own cipher. That's fine. Let's keep going. Kirchhoff's principle says that when determining the robustness of a cryptographic, I've been changing crypto to cryptographic. That's neither here nor there. You know, if you don't want to take that suggestion, you don't have to. But that's fine. To be fair, it sounds nicer the corrected way. Yeah. So this is where cryptographic system. Why can't I type? Okay, Kirchhoff's principle says that when determining the robustness of a cryptographic system, it should be assumed that the attacker knows the encryption and decryption algorithm. Okay, sure. So my naive response here, this does not include any pre-shared or secret keys. Could we maybe talk about what that means a little bit? So this is specifically for just maybe a sentence here. What does this mean for algorithm development? Does it mean... So Kirchhoff's principle says that when determining the robustness of a cryptographic system, this is for testing the system. Okay, no, actually, I'm reading it wrong. I think it's correct. This is actually fine. You're determining the robustness of a cryptographic system. That's actually correct. I was just being dumb and it took me a second to understand. Okay. With the advances in technology, cryptography often has its limits. All right, let me change this really quick. There is a comma missing. With advances in technology, comma. There we go. All right, keep going. Many formerly thought hashing algorithms became obsolete. Robust. Because the computer formerly robust. I'm going to say robust is probably the word we're looking for there. State of the art, robust. I'm going to say state of the art is what I'm going to say. Feel free to change that. Between quote. Wait, is there an easier way to do... Wait, you're telling me there's an easier way on GitHub to do this other than suggestions? Feel free to tell me how. Many formerly state-of-the-art hashing algorithms became obsolete because the computer... I'm also going to say have become. Have become. Obsolete. Because the computers used to crack them have gotten faster, have become faster and better. I'm just being a big stickler here. Again, you don't have to do everything I'm saying. I'm just saying this is how I would edit it if I were doing it. Many formerly state-of-the-art hashing algorithms have become obsolete because the computers used to crack them have gotten faster and better. Update comment. Keep going. The keys for RSA. Now, RSA has not been defined, I don't think. Have to be longer or different or stronger. Longer or different and stronger algorithms have to be used. Another field that cryptography will have to face is quantum computing. Quantum computers will have a big impact on cryptography and especially asymmetric cryptography. This whole set of problems is summarized in the field of post-quantum cryptography. Okay, let's go here. And I'm just going to do a few quick changes here. I almost feel like this could be removed. All right, add a review comment. Quantum computing. I feel like quantum computing shouldn't be capitalized, but I don't really know enough to say. So I feel like it shouldn't be capitalized, but that's just me. Lowercase q, lowercase c. All right, go here. I think it's fine. Probably fine. All right, add review comment. Quantum computers will have a big impact on cryptography. Suggestion. I should have just done this all in one block, but I didn't. So you guys are going to have to deal with a lot of comments here. Here, computers will have a big impact on cryptography and especially asymmetric cryptography. Add review comment. The whole set of problems is summarized in the field of post-quantum cryptography. Or copy and paste. I should have done that. That's what I should do. But here we are. Suggestion. I'm being super sticky. I'm sorry about that. But again, you don't have to take all these suggestions. I don't know if that should be capital or not. All right, add review comment. Okay, we're getting there. We have a little bit more to read, and then we're done. Don't worry, you'll learn to be more productive. Oh boy, I hope one day I'll learn to be more productive. Gohaku, thank you so much for following a few minutes ago. Okay, symmetric cryptography is often called symmetric because the key that is used is the same for encrypting and decrypting. For this to work, Alice and Bob both need the same key, which they have to share before communicating. Some examples for symmetric cryptography are Caesar cipher. Alice and Bob rotate the alphabet by n characters and use that as a table to encode and decode their message. Rot 13, this is a special case of the Caesar cipher where the alphabet is rotated by 13, hence Rot 13. Permutation cipher, here you choose a permutation pi, i.e. pi is 3, 1, 2, 4, and reorder the alphabet, the letters according to that pi, which is the key. Zohr encryption, this method works on bit strings and combines the message and key of equal bit length with the Zohr operator. To decrypt, simply Zohr again with the same key, right? Data encryption standard, this is a newer encryption algorithm which was standardized in 1977. It has since been deemed insecure and superseded by AES. AES, or Advanced Encryption Standard. The actual algorithm is called Rigindale. Like with Zohr or DES, you generate a bit string. You use 128 or 192, 256 bits long, and Blowfish. There we go. This algorithm also was a good contender for the AES, but lost to Rigindale. Again, I don't know how to pronounce that. This section is currently a work in progress, and all these methods will have corresponding chapters. That'd be super cool. That'd be super cool if that would happen. IJ, hey, and A is A, So, wait, let me try this. Hey, Ray, wait, Raydal? Is that it? Raydal? Raindal. Sure, okay, Raindal. Yeah, that makes sense. I'm going to put a quick message in here. I think everything's written well with this section. Would it be possible to also add some citations here? Just add something like, I think it's cite. Oh gosh, let me actually see what it is. Over here, that's fine. I'll just make this huge. Not that big, huge. There we go. And then we go to CD projects, algorithm archive, CD Computus. Computus. All right, VI Computus. Come on. .md, and let's look for site thing, and then I think it's site. There, I always forget how it's done. And then at the bottom we have to do, there should be a cite method as well here. Where is it? Bibliography? Bibliography. It should be added at the end. This. At the end, be sure to add the citations to literature.bib. All right, perfect. Add view comment. Good. Okay, asymmetric cryptography. Asymmetric cryptography is sometimes called public key cryptography or PK crypto in short. Sure. I was going to look up the syntax for function pointers, and now I'm at compound literals, of which I'd never seen before. We should probably add citation for the original papers, or FIPS or something for AES. I thought I knew. See? Look, function pointers are tough. Man. Okay. Let me read this as well. And then I think after reading this, we should be good to go. Interaxis CA, thank you so much for following. And also, let me just try something really quick. I don't know if I need to... Now I'm super paranoid about video and audio desync, but I think it's probably fine. It looks fine to me. Okay. Good. Asymmetric cryptography is sometimes called public key cryptography or PK crypto in short, because Bob and Alice both need a shared public key and a private key they keep to themselves. These algorithms are called asymmetric because what is encrypted with the public key can only be decrypted with a private key and vice versa. This can be used for a number of different applications like digital signing, encrypted communication, or secretly sharing keys. For example, if Alice wants to send a message to Bob and this message has to be kept private. Yep. Okay, let's go here. For example, if Alice wants to send a message to Bob and this message has to be kept private, that's it. Here we go. Be kept private, comma. Alice will encrypt the message with Bob's private key. Okay, keep going. I missed something. Now I don't like C very much. I'm sorry. I liked C, now I don't like it very much. Wait. Right, there we go. Now only Bob can decrypt the message again and read it. If Charlie were to alter Alice's message, Bob couldn't decrypt it anymore. If Bob wants to make sure the message is actually from Alice, Alice can encrypt the already encrypted message with her private key again. This is to keep Charlie from sending forged or altered messages since Bob couldn't decrypt that layer with Alice's public key. Some examples for public key cryptography are RSA. This algorithm calculates the public and private key from two very large primes. It is hopefully near impossible to factor the product of two such primes in a feasible amount of time, or ECC, elliptic curve cryptography. Here you calculate the private and public key from 2 points on an elliptic curve. This has the positive side effect that you need smaller numbers than non-ECC algorithms like RSA to achieve the same level of security. Let's see, I'm considering jumping into Rust. Is Rust as low level as C? I think so. With Bob's public key, not Bob's private key. Oh, that might be a big change. Public key, I can't speak, I'm so sorry. Public key. Here, right? So, for example, if Alice wants to send a message to Bob and this message has to be kept private, Alice will encrypt the message with Bob's public key. Right, exactly. Public. Okay, update the comment. And then like before, it'd be nice just to have references. Like before. A few references would be nice. Okay, add here. And then down here, we need to say, this is so, edit, this means it just allows LaTeX to work without refreshing. Okay, update comment. I think text-wise this is pretty good to go. I'm gonna request changes, and I say text is pretty good. I made a few suggestions. Feel free to ignore some of them. Also, it would be nice to have at least one image or something. Okay. Okay, that's good. Cool. Submit review. Oh, okay. Good. So we spent, what, 3.5 hours doing algorithm archive work today. I'm a bit shot. I think this is a good place to go ahead and close. What I'm going to say is every single day from now on, I will be doing some form of chapter content on the algorithm archive. Well, I'm going to try to do some form of chapter content on the algorithm archive. This could be rewriting already existing chapters, or it could be reviewing chapters that people have submitted. What I'm trying to do is just make it so, we start to get content into the algorithm archive very regularly. Whether that content is written by me or is written by someone else, that doesn't matter too much. But the fact is, the algorithm archive, the only way for the algorithm archive to survive is with more content. And, if that's coming from me or someone else, it doesn't really matter. I ultimately want the chapters to be of reasonable quality, and that's just such a hard thing it's such a vague thing to define, and that's why I've been so bad with this. But look, we got to get stuff in, we have to, bridge that gap, and, now's a good time to do that. Let me see who's live and who we might want to raid at the end of stream. Okay, look, I'm going to say something, and you guys are going to be really pissed off about this, and I'm sorry, but I am looking at it. I'm actually not in a mood to raid anybody right now. I know that sounds really dumb, but every time you raid someone, like I said before, there's the possibility that like, hey, how was stream, blah, blah, blah. Maybe I'll do Gamozo. Let's do Gamozo then. And I'll just be like, hey, gotta go. That's just how it's going to be. Anyway, thank you guys so much for coming in. Let me go start the raid on Gamozo then. Raid, Gamozo. And that's it for now. So thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I'll see you guys around next time for the next episode of Simuleos. Should be tomorrow. Hopefully it's going to be a somewhat long stream, and we can just start working on histograms and stuff again. Pretty excited for it. And yeah, I'll see you then. Bye guys. Oh, it's up here.